Right now, Europe is dealing with far more than a standard summer heat wave. The continent is being split in two by an atmospheric pattern that is trapping intense, record-breaking heat between two separate storm systems, while millions of people are left right in the middle of that clash. On one side, temperatures are soaring to dangerous levels. On the other, violent storms are bringing hail, flooding, and damaging winds. If you want to understand why this is happening and what it could mean for people across Europe in the days ahead, it all starts with the pattern meteorologists are watching most closely, the Omega Block. That name comes from the shape it forms in the atmosphere, which looks like the Greek letter omega when drawn on a weather map. Samantha Burgess of the European Center for Medium-Range Weather Forecasts has described it as something like a traffic jam in the sky, because once it forms, it can lock heat in place for days or even weeks. The reason is simple. A ridge of high pressure builds up and pulls hot air northward, in this case from North Africa, and then gets trapped between two low pressure areas, one often sitting near Portugal in the Atlantic, and the other over Central Europe. That high pressure ridge between the two lows is what gives the pattern its shape and what keeps it stuck. Normally, Europe's weather changes because the jet stream keeps systems moving from west to east. A hot spell usually doesn't last long before another front comes through and brings cooler, more unsettled weather. But an Omega Block shuts that process down. The jet stream bends sharply north around the ridge, then dips down again on both sides, creating the omega shape that blocks the usual flow. Once that structure locks in, the surrounding systems can sit nearly motionless for a week or longer, and that is exactly why these events can create such long-lasting and punishing heat. The core of the block, directly beneath the high-pressure ridge, gets the worst of it. Sinking air suppresses cloud formation, the skies stay clear, and heat builds day after day with very little relief. But on either side of that ridge, conditions can be completely different. The low-pressure zones pull in cooler, unstable air, which creates the perfect setup for thunderstorms, large hail, strong winds, and flash flooding. So while one part of Europe bakes under a heat dome, another can be dealing with dangerous storms just a few hundred miles away. If you want weather explained without the jargon, this is exactly the kind of pattern that shows why it matters. And this year's version has already turned extreme. France recorded its hottest temperature since national records began in 1947, with the mercury reaching 44.3 degrees C, or about 112 degrees F. Even more striking, the country posted a national average temperature of 30 degrees C across an entire day, a level that is almost unheard of when you remember that this average includes cooler coastal regions and higher altitude areas as well. At the same time, weather services from Berlin to Prague issued red alerts for extreme fire danger, because low humidity and shifting winds made the landscape dangerously easy to ignite. A single spark in those conditions could quickly become a major wildfire. The human toll has been severe too. More than 40 people drowned across France in a single week, often after trying to escape the heat in rivers, lakes, or ponds without proper safety measures or lifeguards. At the same time, thousands of homes lost electricity as air conditioning demand pushed power grids beyond their normal summer limits. Several nuclear plants in France and Switzerland also had to reduce output or shut down because the river water they rely on for cooling became too warm to use safely. That detail matters because it shows how far the effects of this kind of heat can spread, far beyond just uncomfortable afternoons and sleepless nights. Nuclear power plants need to draw in river or seawater to cool their reactors, then release that water back into the environment at a safe temperature so downstream ecosystems are protected. But when the river water is already too warm before it even reaches the plant, operators are left with a difficult choice. They can reduce power output to avoid adding too much more heat to the water, or they can risk damaging aquatic life by releasing overheated water into an already stressed river system. In this case, multiple facilities in France and Switzerland chose to scale back operations rather than take that risk, which in turn put even more pressure on power grids already struggling to meet record-breaking air conditioning demand. What makes this situation even more alarming is that this is not Europe's first Omega Block of the summer, and it may not be the last. A major heat dome driven by the same kind of pattern struck in late June, breaking hundreds of local and national temperature records across France, the United Kingdom, Switzerland, and Germany before it finally began to move. But instead of giving the continent a real break, forecast models quickly pointed to another heat dome building in early July. The most dangerous phase was expected to move from Spain, Portugal, and southwest France around July 7th and 8th, then spread deeper into France, the Benelux countries, Germany, and the Alps from July 9th through 11, and possibly remain locked in place through July 12th to 14 if the blocking pattern held. That back-to-back setup is one of the reasons forecasters are so concerned. The first heat wave already dried out soils and baked roads, buildings, and entire cities from the ground up. With less moisture left in the soil, there is less evaporation to help cool the surface naturally. That means the second wave can intensify even faster, because one of the atmosphere's built-in cooling mechanisms has already been weakened. Meteorologists have warned that this second event may heat up more aggressively than the first for exactly that reason. What also makes omega blocks so dangerous is what happens at their edges. While the center of the block keeps hot air locked in place, the boundary zones along the northern and eastern sides become breeding grounds for severe thunderstorms. Those storms can produce large hail that damages cars and crops, straight-line winds strong enough to bring down trees and power lines, and flash flooding that overwhelms drainage systems in cities that may have spent the previous week under intense heat with barely any rain. That creates a very difficult situation for both emergency planners and ordinary residents, because conditions can shift from heat warnings and wildfire alerts to severe storm watches in less than 2 days. This rapid change between extremes is what meteorologists often call a whiplash effect. It is not just inconvenient. Infrastructure and emergency systems that are built to handle one type of crisis at a time can struggle when heat, fire risk, heavy rain, and flooding all arrive in the same week. And because the ground has been hardened and dried by prolonged heat, when heavy rain finally does arrive, it often runs off instead of soaking in, which makes flash flooding even worse. That is why forecasters pay close attention to these boundary zones whenever an omega block sets up over a populated region. The bigger question is why this pattern keeps showing up during recent European summers. Scientists have not reached a final conclusion on whether climate change is directly making omega blocks more common, and that remains an active area of research. What is much clearer, according to researchers like Burgess, is that once these blocking systems form, the heat they produce is now far more dangerous than it used to be. Human activity has already raised the planet's baseline temperature by about 1.3 degrees C compared with pre-industrial levels. So when an omega block traps hot air over a region, it starts from a much warmer baseline and drives temperatures even higher than the same pattern would have done decades ago. Researchers estimate that today's European heat waves are now running about 2 to 4 degrees C hotter than they would have been without human-caused emissions changing the underlying climate. That difference helps explain why these events have become so deadly. In 2022, heat waves across Europe were linked to tens of thousands of deaths and roughly $40 billion in damages. In 2023, a heat wave nicknamed the Cerberus event, after the mythical guardian of the underworld, brought some of the hottest temperatures ever recorded in Europe and was tied to more than 47,000 deaths across the continent. And reports on the 2024 heat season found even worse totals, with researchers documenting well over 62,000 heat-related deaths across Europe in that year alone. Each of those events shared the same basic structure, a stalled high-pressure block trapping heat over a continent that is already warming. This year's back-to-back omega blocks appear to be following the same pattern. Europe has seen this before as well. A horseshoe-shaped omega setup was identified as the key driver behind a major heat spell in France in June 2025, and similar blocking patterns have shown up repeatedly in recent summers. The phenomenon itself is not unique to Europe. It can also happen over North America and the Pacific, anywhere the right mix of high and low pressure systems locks the normal eastward flow of weather in place. What seems to have changed is that Europe has experienced a measurable increase in these blocking systems over recent decades, even though scientists are still debating how much of that rise comes from climate change and how much from natural atmospheric variation. Public health officials across the affected countries have been very direct in their warnings, and for good reason. When nights do not cool down enough, the body never gets a real chance to recover between scorching days. That kind of overnight heat retention has been a major factor in past European heat deaths, and it is once again at the center of official advice. In several countries, libraries, museums, cinemas, and other air-conditioned public buildings have been opened as cooling centers for people who do not have reliable air conditioning at home. That matters because air conditioning is still far less common in much of Europe than in places like North America, where buildings were more often designed with hot summers in mind. In Europe, many older buildings were built to retain warmth through cold winters, not to release heat during long summer hot spells. That design made sense for a long time, but it is becoming a serious problem as extreme heat grows more frequent. Thick masonry apartment buildings, especially older ones, can trap daytime heat indoors for days, so even at night, temperatures may barely drop. For elderly people living alone, or anyone without good cooling, that can mean no real chance to recover before the next day's heat begins building again. There is also another layer to these omega blocks that does not always get the same attention as the heat itself. When these systems pull air north from North Africa, they often carry Saharan dust with them. That has happened again this year. The dust has drifted across Spain and Portugal and moved farther north into parts of Western and Central Europe, lowering air quality in cities that were already under serious heat-related health warnings. For people with asthma or other respiratory problems, the combination of extreme heat, high humidity in some areas, and dust-filled air creates yet another serious health risk. Officials in several countries have warned specifically about that overlap because it can make an already dangerous situation even worse. One important point that meteorologists keep stressing is that the exact details of this second heat dome are not fixed in stone. The forecast dates, peak temperatures, and duration are still scenarios, not guarantees, because blocking patterns can shift, weaken, or intensify as new data comes in. That is why forecasters keep telling people to check daily updates instead of relying on a forecast from a week earlier. The line between the scorching core and the stormy edges can move within a day or two, and that can change which places face the worst heat, the strongest storms, or the highest flood risk. So what does the coming stretch actually look like for the roughly 100 million people living across the countries most directly affected by this pattern? The answer depends on how long the omega block holds. Conditions should begin to ease only once the block weakens and the jet stream starts moving normally again, pushing the stagnant ridge out of place and letting more typical summer weather return. Until then, Europe remains locked into the same split pattern: intense, record-challenging heat at the center and increasingly storm-prone boundary zones on either side. That is why this system deserves so much attention. It is not just another uncomfortable hot spell. It is a rare and powerful atmospheric setup that is literally dividing the continent into two different weather worlds. In one, heat is building to dangerous levels with little relief. In the other, storms are forming along the edges with the power to bring hail, flooding, and destructive winds. Millions of people are caught in the transition between those two extremes, and that is what makes this event so serious. Wildfire risk is one of the most immediate threats tied to the pattern, especially in southern France, Spain, Portugal, and parts of the Balkans. In those areas, dry vegetation from earlier in the summer is now sitting under intense heat and low humidity, creating ideal conditions for fires to start and spread quickly. Firefighting crews across multiple countries have already been stretched by blazes linked to the earlier June heat dome, and forecasters have warned that another round of severe fires remains a real possibility if this second wave strengthens the way models currently suggest. That threat becomes even more serious because wind can change suddenly along the boundary of the block. A fire that seems manageable one hour can shift direction quickly the next, making it harder for crews to contain and harder for residents to prepare. That is part of what makes these weather setups so difficult to manage. They do not just bring one hazard. They layer danger on top of danger, turning heat, fire, storms, and flooding into a single connected crisis. And this is why climate scientists and public health experts are paying so much attention to the broader trend, not just the individual headlines. Even if researchers continue to debate whether omega blocks are becoming more frequent because of climate change, there is no real dispute that the heat they produce is now more harmful than it was in the past. The atmosphere may create the same basic pattern, but the world it is acting on is much hotter, which means the consequences are more severe, more widespread, and harder to recover from. That is also why overnight conditions matter so much. If the temperature stays high after sunset, the body never gets the recovery window it needs. Over time, that compounds heat stress, especially for older adults, young children, and people with underlying health problems. In past European heat waves, that lack of nighttime relief has played a major role in the rise in deaths, and officials are once again warning people not to underestimate it. A hot day is dangerous, but a hot night after an already punishing day can be even harder to survive. Cities and towns across the affected region are trying to respond by opening cooling centers and urging people to seek shaded, air-conditioned spaces during the hottest hours. But the reality is that not everyone can do that easily. Some people work outdoors, some live in homes that hold heat well into the night, and some simply do not have access to reliable cooling. That is part of what makes Europe especially vulnerable during events like this. The infrastructure in many places was not built for repeated extreme summer heat, and the pressure is showing. The same is true for power systems. Air conditioning demand rises sharply during heat waves, but the grids have to handle that demand at the same time that power generation can become harder to maintain. When nuclear plants reduce output because river water is too warm, the strain only grows. It is a reminder that a heat wave is not just a weather event. It becomes an energy problem, a health problem, a transportation problem, and in many cases, a water problem too. As the omega block continues to shape this summer pattern, forecasters are watching closely for any shift that could change the balance between heat and storms. If the block holds, the same split weather setup will continue. If it weakens, the continent may finally get a more typical sequence of moving systems and changing conditions. But until that happens, the risks remain concentrated in exactly the way the pattern suggests. Extreme heat in the center, violent storms on the edges, and very little relief in between. That is the core reason this event stands out. It is not just the intensity of the heat, and it is not just the storms. It is the way both extremes are happening at the same time in the same broad region, because the atmosphere has essentially stalled. Europe is being divided by a weather pattern that traps danger in place and then pushes the worst of it toward different places depending on where you stand. For some communities, that means days of punishing heat. For others, it means fast-moving storms, hail, and flooding. For many, it means both. And while the forecast will continue to evolve, the basic message from meteorologists is already clear. This is a high-risk setup, and it will not resolve quickly unless the omega block weakens and the jet stream resumes its normal west-to-east flow. Once that happens, the locked ridge should move out, the stalled systems should break apart, and more ordinary summer weather should return. But until then, the continent remains under the influence of a pattern that is unusually persistent, unusually disruptive, and unusually dangerous. The wider climate context makes that even more important. Europe is already hotter than it used to be, and that means every locked-in heat event begins from a worse starting point. The same atmospheric pattern that might once have caused an uncomfortable hot spell now has the power to trigger record temperatures, overloaded grids, water stress, wildfire danger, and deadly health impacts. That is why researchers keep returning to the same conclusion. Even if the omega block itself is still being studied, the risk it creates in today's climate is no longer in doubt. So when you hear that Europe is splitting in two, this is what that means in practical terms. A ridge of high pressure is trapping scorching air over the center of the continent, while low pressure systems on both sides are feeding stormy, unstable weather around its edges. That leaves millions of people caught in the middle of a fast-changing, high-stress pattern that can shift from heat alert to flood warning in a matter of hours. It is a stark reminder that weather is not just something happening overhead. In events like this, it shapes daily life, public safety, energy systems, and even the ability of whole regions to function normally. And because this pattern is still unfolding, the next few days matter a great deal. Forecast updates could shift the timing, the hottest zones, or the storm tracks, but the overall danger remains clear. Europe is in the middle of a severe atmospheric split, and until that split closes, millions of people will continue to face the consequences on both sides of the line. If you want more clear, fact-based breakdowns like this, subscribe to the channel and turn on notifications, because this story is still developing and the next update could be just as important as the last.